Hello, everybody. So today we're going to be talking about how to find the area of a triangle, but we're using trig. Okay, and so we have three different triangles here, And once you find the area of the following triangles, I'll move this up a little bit so you can take a look here. Again, aim is how we find the area of a triangle using trig, and we now find the area of the following triangles. So move this up a little bit so you can see. Okay. So yeah, instructions are to find the areas. Now, from what we learned before way back in probably middle school or earlier, area of a triangle can be found by taking 1/2 times the base of the triangle times the height. Now, very important in this case, the base and the height are always going to be perpendicular to each other. So base and height are perpendicular to each other. So we're going to find two measurements for the triangle, and sometimes the height will be also known as the altitude of the triangle. So we talk about altitude and height basically mean the same thing. And so let's take a look here. We see in this case our first triangle here, take a look. Okay, so we have this leg here is 10. This is a right triangle. This is 10, and this of course is the other leg 8 because they're right triangle. And here both legs are perpendicular to each other, therefore they'll be the base and the height. And so here we'll take the area to be 1/2 10 times 8. And so 1/2 10 times 8, okay, so we'll get in this case, well, 1/2 80 should be 40 units squared. Okay. The second problem, take a look here. We see that the altitude of the triangle is going to be 9. So here 9 and the base here is 12. So we'll find here the area to be 1/2 times 12 times 9. Now I'm going to multiply the half times 12 to get 6 first, and 6 times 9 should be 54 units squared. Okay. Now, the third triangle, well, this 7 here is not the altitude. It's not perpendicular to this base of 21. We need to find the height. And so now the question is, how do we find the measure of the height? But they did give us 45 degrees. So think about this now. How can we find the height? Maybe we should draw the height first. So we're going to draw our height here. Okay, and find this measurement. Wait a minute. I think I see another triangle besides the triangle we have here to start off with. It looks like the triangle we have is the triangle formed by this altitude. Now we know 45 degrees, and we know this is 7, and we're trying to find this part here, okay? But this part is the leg opposite of the angle, and this is the hypotenuse. Maybe we can find the height using trig. In this case, since the angle is 45 degrees, and we have the leg opposite as well as hypotenuse, we're going to use the sine ratio. So the sine, again, the sine ratio is the leg opposite over hypotenuse, in case we have forgotten this. And so sine is opposite hypotenuse, and so we have the sine of 45 degrees is equal to the leg opposite over 7. Okay, so the leg opposite is going to be our height, and so we now get cross multiply, and we get the leg opposite. Okay, we'll call it little h. Okay, little h here, so instead of O, it's a 0. Our little h is going to be, little h here is going to be 7 times the sine of 45 degrees. Okay. So our height here will be now sine of 45 degrees. If you check your calculator, will be in this case, well, that'll be, I believe, 0.7071. So since that goes on forever, so we'll keep it this way here. Sine of 45 degrees. Well, we found the height, but we'll try to find the area of the triangle. So here, the area of the triangle is going to be 1/2 base times height, or in this case, 1/2 times 21 times 7 times the sine of 45 degrees. Now let's enter a calculator, and our square units will be in this case. So let's take a look. All right, so from our, let me clear all this from our last lesson. So we have in this case 1/2 the same as 0.5, right? 1/2 is 0.5, and then we're taking the 21 times 21. Okay, that's the base, and the height we found to be times 7 sine of 45 degrees. And we get, in this case, 51.97, which will round off to, well, if we round to nearest 10, it would still be 52.0. So we'll take it as 52 units squared, 52.0 units squared. But the idea now is that notice that we did not have a height. We can find it if we had this measurement here, these two legs, and the included angle. Now our idea comes in this case to maybe from a formula to be able to find the area of a triangle if we have two sides of the triangle and the included angle, almost a SAS situation, side angle side, the two sides and the angle included. So now let's take a look here. We want to find h in terms of a using trigonometry. Okay, and so here, let's see now. Well, here's angle C, and B is this measurement. Angle C is this angle, and of course here we have angle A. Our right angle is right here. Okay. And so here from this point of view, we're going to now say, okay, our height only involved in this case is going to be our height and A, which of course is the hypotenuse. Opposite hypotenuse, we have the sine of C equals h over A. Our h value, which is our height we're looking for by itself, will just be h equals A times sine of C. So you're saying, I'm so used to using numbers, but remember the rules for numbers are the same as the rules for letters. And so we're going to leave this height as A sine of C. The area of the triangle is 1/2 base times height. Here our base is B, so it would be, our area of the triangle would be 1/2 the value of B times the height, which we said is A sine of angle C. And so here, we put it together, and I like putting stuff alphabetically. The area of the triangle is equal to 1/2 the side of A, measure side A, times the measure side B, times the sine of angle C. Now, this will be now our area of a triangle formula using trigonometry, specifically the sine ratio. So area of, we call K, a triangle ABC, is 1/2 AB sine C, or 1/2 BC sine A, or in this case, 1/2 AC sine B. So now trying to figure out why we are stuck here with these. Okay, there you go. Okay, maybe not. Okay, so here the idea is that we can find the height based upon any of these things. For example, the lowercase letters represent the side opposite of the angles. So here, the lowercase a is opposite of big angle A, the lowercase b is opposite of angle B, and the lowercase c is the measure side opposite angle C. So to find the area of a triangle, we multiply two sides by the sine of the angle included between them, and then divide by 2. This is our formula for area of a triangle. Okay, now in this case, keep in mind, we don't need to have letters A, B, and C. Just know that if we know the two sides of the triangle and the measure of the angle, we have enough to find the area of a triangle using sides.